Hello, everybody. So this is the video for lecture one in week 15. So this is the last topic that we're going to cover in this class. And so it's going to be file input and output. And this is the second time I'm trying to record this. The first time I recorded this video, um, I wasn't sharing my screen. So I recorded an hour worth of audio and nothing else. But this time we're good to go. And this is lecture 15, file input and output. It goes with week 15 reading and homework. There will be a video um, for, going over the Zybooks exercises for these. And also there'll be a video for lab 15. Lab 15 is just a video that covers what we're doing in this video, um, but it's in the lab assignment. Uh, all right. So with that said, let's go ahead and get started. So I have these lecture slides, lecture 15 file input and output PDF, and I've already got them downloaded, I believe. Here they are. And so we'll just jump in. And so as we're doing this, I'll do some stuff here and then head over to Eclipse to type up an example from scratch, then come back like I do in most of the videos. So what we're going to learn how to do is use file input stream and file output stream. So if you're reading a file, it's going to be an input stream. And if you're writing a file, it's going to be an output stream. And then once you have your file set up, the way you read from a text file is using scanner, which you already know how to use because you've seen, scnr.next, scnr.next line, scnr.next double, and scnr.next int. So you'll just use those again. So instead of reading from the keyboard, you'll read like words from a file instead of the keyboard. And for writing, it's similar. You set something up as a file output stream. And then after you do that, you set up a print writer. And print writer has print, print line, printf, etc., which you also know how to use. So you print just like you're printing to the console, but you're not printing to the console. You're printing to a file. Cool. So that's what we're going to be doing today. So we want to jump in with an example. So I'll head over here to Eclipse and I will create a new Java project. I'll call this file examples. And then I'm going to expand that, click on SRC, right click, and create a new class. And so we'll do separate examples for input and output. So I'll call this file input. And I'll check the box for public static void main. Cool. So file input's just what I named this class. So if you're going to read a file, you need these imports at the top. So file input stream is, as I mentioned, necessary for reading a file. Scanner, we're already familiar with. You've used scanner many times. And this middle one here, IO exception, that's how we deal with errors. So this isn't technically required for file reading, the middle one, but the way that we're going to do it, it is. So you start out with those. Now, the next thing you need to make sure you do, and this is going to be for reading and for writing, is we're going to have to add this extra word, these extra words here, throw IO exception, to a specific place in the header for the main method. So I have to select all this and type throws IO exception here. So notice the location, right? It's between like the parentheses here and the curly brace. That's a weird place to put something. We haven't done that before, but it is necessary. I'll even show you that it is necessary in a minute. Cool. So we're reading a text file is what we're going to be doing. So we need a text file to read. So let's create that. So I'm on a Mac right now. You might be on Windows PC. So if you are, then that's going to be a little bit different here. I'm gonna I have this is a terminal here. You don't need to pay much attention to this at all. I'm just going to go to my documents folder and I'm going to just create a little text file real quick. I'm just going to call it, I'll call it example.txt. Oh, it's already there. Never mind. Here's line one of my text file. This is line two. One more, and I have 3 lines. Doesn't matter what it says. It's just, okay, fine. I have 3 lines of text. I'll save it. I'll close it. That's all I needed. I just wanted a text file somewhere. Okay. Now, if you're in Windows, right, I think you can just right click in a folder. Like if you open up your like Explorer, I guess it's called in Windows, and you right click on Windows, you can there's a new text file or new document or something in there, and you can create a text file anywhere you want. Um, you can see I've got my example.txt right here, and if I open this up, open it up, you'll see it's just the same thing I just typed in. All right, so that's just a file with a little bit of text in it. Now, back over here, so we've got these imports at the top, and we've added throws IO exception. So what's next? So what's next is we have to create this file input stream object. So I'll copy paste this. You can type it from scratch if you want. And this is how it works. So we need a file name in a string. Well, we don't need it because you could just type it in here, like in quotes. You could be like example.txt. So you can type it in there, but you could also put it in a string and then put the string in here, which is what we're doing. So I'll just put file name here. File name is just the name of the string. It's not a special name or anything. So string file name, example.txt, file input stream. So that's why we needed to include this. File input stream. You can call it whatever you want. I'm calling it FIS for file input stream. Very original. Equals new file input stream file name. So what this does is it like sets up your file to open, right? So we are get our file ready for reading. Okay, so that's what we do. And after you set up the file input stream, the next thing we need to do, well, that's not what I want. I should have gone to preview, which is there. The next thing you need to do after that is to declare a scanner. So I'm going to ignore most of this and I'm just going to copy the scanner declaration. Go. Stop it. Go. Okay. So you declare a scanner object. And so the scanner object, as you can see, is scanner scnr equals new scanner. We do that a lot, but normally in here we type system.in, right? And system.in, it says, as it says here, the standard input stream. The stream is already open and ready to supply input data. Typically, this stream corresponds to the keyboard input, right? So you type system in here when you're going to read from the keyboard, but we're not reading from the keyboard. We're reading from a file. So what goes in here now is the file input stream. So if I called mine FIS and I call this FIS, right? So these names have to agree in order for this to work. And at that point, we're ready to read from our file. The way you would read from your file is, well, you need to read it into something. So like if I make a string and I call it like my word equals, and I do, let's say, how do we read using scanner? It's scnr dot, and to read one word, it's next, right? Next to read one word. Now, when I run this, we're going to get an error. Run, run. Let me put the console down here. So we get an error immediately, and the error, as it says, is example.txt, no such file or directory. So that is an exception. And to even try to run this code, that is why I had to have throws IO exception up here. It won't even compile without throws IO exception up here because of the possibility that something goes wrong reading the file. If you think about it, almost everything we've done in Java before was all kind of self-contained in the file that we were writing. But now that we're reading files, what happens if you try to read a file that doesn't exist? Or what if you try to read a file, but the file is, you don't have permissions to read the file, right? There's, certain users have permissions to read certain files in a lot of operating systems. So what if you don't have permission to read the file? Or what if the file is corrupt, right? There's a lot of things that can go wrong when you're trying to access files on a computer that are not under our control. And every time an error happens, that's called an exception, and they need to be dealt with somehow. And so the way we're dealing with them now is just by putting this throws IO exception up there and just saying, hey, there might be errors, but we don't care. So we'll just move on. Um, Having said that, what is the error that we are experiencing is that this example.txt file doesn't exist. And this example.txt file doesn't exist because uh, it's looking for this in a different place than I put it, right? So right now I just have example.txt here. That's the name of a file, but it's not the location of a file. So if I open up Finder in my case and I go over to my documents here and I right click on example.txt, if I hold option, this is a Mac thing. If I hold option, there's a copy example text as path name, and that copies the name and the path. So where this file actually is users ghogan42 documents example.txt. Okay, so if I have the whole path in there and I do this, now it says, well, it doesn't say anything because what we did was we opened the file and we read one word, but we put the word into a string called my word and we didn't do anything with it, right? So to see if it worked, let's try to spit it out to the console. So let's just do system.out.println my word. Okay, run, and it says here. And of course that makes sense because if we look at, well, everything's so slow right now because I'm doing AI training at the same time as this. Um, if you look up here, the first word is here, and I read one word and printed it, so it's here. If I change this to next line to read an entire line of text, then we should get the entire first line printed out. Here is line 1 of my text file. Of course, if I do that, then maybe the variable shouldn't be called my word, maybe my line or something. All right, so here's line 1 of my text file. And if I want to read another one, I could do this thing again. We wouldn't have to redeclare the string. So like if I do my line equals scnr next line, it's going to read the next line. So every time you read, it's moving on and going further in the text file. So the first time it reads a line, it's reading the first line. The second time it reads a line, it's reading the second line. Third time should read the third line. One more, and I have 3 lines. Let's do a fourth. Okay, let's do a fifth. Okay, we get an error. It says no line found. And if we look in example.txt, let's open it up. We should see, where's the text editor? Here. If we open this up, and I'm going to make this, actually highlighting it is a good way to do it. So you see there actually is 4 lines. So first line has text, second line has text, third line has text, fourth line is blank, but that it exists. There is a line here. And that's why there's like a blank line here. But then when it tries to read a fifth line, there's no fifth line. So there's no fifth line. So when you try to read a fifth line, you get an error. And the error is very simple, no line found. You tried to read a line, but there was no line. And so because of that, just separating this out a little bit, because of that, we need to stop reading the file when we get to the end. And so rather than just keep reading like we're doing now, like read a line, 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 we're trying to read 5 lines. We don't want to do it by copy pasting the same lines however many times we have. We would like to put it in some kind of loop or something. And so what you do if you're trying to read an entire file is you make a while loop. And there's this special function called has next. And so scanner, we can go has next. See has next. And it says returns true if the scanner has another token in its input. So what that means is that it's checking if there's something to read. So we can check if there's something to read and then we could read it like that. And so if we read our file this way, as long as there's something to read, we're going to read a line and then print it out, then we should be able to print the entire file. There we go. Um, we can print the entire file and we're not going to have any errors because putting it in this while loop, it's only going to read as long as there is something to be read. And then when there's not, SENR has next is going to return false, and we're not going to try to read it anymore. So this little while loop reads a file until the end of the file. And that is essentially your first problem from Lab 15. So your first problem for Lab 15 is going to be to read a file and spit it out to the console. Now, another thing is when we're done reading files is we should close our file. So you could either close the file input stream or you can close the scanner. I would close the scanner just with scnr.close. And you can see adding that there, and I saved this, and it got rid of a little, warning up here as well. So when you're done reading a file, you close the scanner, and that lets the operating system let go of the file. So, all right, cool. So we now have written a program that reads a file from the beginning to the end. It just puts the lines into a string and then prints them out, but that's fine. It reads it. If you make this text file have more lines, right? And you save it and we run our code, you can see it just will read all the way from the beginning to the end. You don't have to know how many lines to read or anything like that. Cool. So let's go back over to the slides and go through these. So after we declared the scanner, we set up this while loop. It says read string or int using scanner.next or scanner next int, process the data as needed, and then SENR closed. Cool. I said closed, but close is what it should be. Here's an example. This is essentially identical to what we just did. The differences are it looks like the scanner was called scanner here instead of SCNR. And the other difference was it just said example text. So let's talk about that a little bit. So I put the name of a file here. You can, or I put the name of the file with its entire path. If you're in Windows, a path might look like this. I'll have to comment out one of these. I'll comment this one out. If you're in Windows, you could, right click on a file. If you're in Windows, you can make a text file anywhere. You can right click on it. And in the menu you get in Windows, one of the options will be similar to this. So like this one says copy example text as path name. It won't be exactly that in Windows, but it'll be like copy as path or something like that. It'll have the word path in there. And I'll try to make a little supplemental video that shows it, but there'll be some kind of copy as path name. And when you copy it and paste it, it'll look something like this. So of course, I'm just making this up right now. So this is what it looks like like on the computers in the computer lab where we have our face-to-face class. I don't know if documents is called documents or my documents. I'll write my documents. I don't know if that's right on Windows. Um, so it would look something like this. Now, the reason I'm doing this now, again, I should make a supplemental one, is if you do copy the path of a file from Windows and it looks something like this, that won't quite work in Java because the way that Java deals with these backslashes is a little bit confusing. Like we know that when you do like backslash in a string, that means new line, and like backslash t means tab, for example. There's all these things, but backslash n means new line, and so on. So Java treats this character, the backslash, as a special thing. And so when you have a path to a file and it has backslashes in it, those backslashes confuse Java. It might even be complaining about it right here. Invalid escape sequences. And it says valid ones are backslash B, backslash T, backslash N, etc. So if you're doing this in Windows and you have full paths like this, every time you have a backslash, you need to change it to backslash backslash on all of them. And that's what it'll take to make that work in Windows. And I should do this in the supplemental video as well. So it'll look something like this. Okay. Um, Having said that, let's get rid of all that and just have example.txt like this. So if you have just a single file and you don't put the path, you just put the file name, we have seen already that when I try to run this, it's going to tell me it can't find the file, right? Example text, no such file. Well, it is looking for that file in a certain location. And so the location depends on, again, whether you're in Windows or Mac OS, but the location is basically the project folder. And so if you just put the file name like this and you want to know where it's looking, what you'd have to do is you have to click over here on your project name. So like file examples, right click, find properties. And when you do that, there'll be a location and users G Hogan 42 Eclipse Workspace file example. Open that. There's an icon for it. When we open this up, we don't need this window here, this properties window anymore. You can get rid of that. Um, but I do need like the Eclipse workspace here. So this is what opened up when I opened up that project folder. And these are folders for every one of my projects. And so this one was called file examples, right? So if I find files examples in here somewhere, I'm going to just sort by or clean up by name. Okay, so we find files examples here, and I open that up. In Mac OS, this is where example text would need to be. So like if I open my other, I think if I open my other um, another Finder window and I go to documents, let's view that as a list and do it by name or something so we can find example. All right, example text is right there. So if I take this example text and I copy paste it into here, so now I have the same text file in this folder. I believe now I can do run, and you see it works again. So you have to have that file in a special folder in order to just put the file name without the full path. So I would recommend you put the full path, and then your text file could be anywhere. It could be on your desktop or your documents folder or wherever you feel like putting it. Okay. Also, again, difference between Mac OS and Windows that I should go over in a little quick other video is that this example.txt could be, it might need to be in the folder called bin, which is binary. So SRC is source, that's your source code for your project. BIN is the binary file for your project. So if you're on Windows, you might have to, like when you go here, you might have to click on your project name and then click on here. And this is where you have to put the example.txt on Windows. Anyway, one easy way to avoid this, again, is you can make a text file wherever you want to put it, and then just right click. On Windows, you should be able to find a copy path option. On Mac OS, you have to hold Option and then do copy example text as path name. And you can put that in there. All right. Having said that, that's basically file reading. Okay. That's what we wanted from file reading. So we want to do file writing now. That's next. So looking in here, we have the full example for reading text files. Now we want to write text files. So it starts out pretty much the same way, except instead of an input stream, we need an output stream. And instead of a scanner, we need a print writer. So in Eclipse, same project, I'm going to do a new class. We're just going to put them in the same project because I'm lazy. They don't need to be. I'm going to call this one file output, again, for no particular reason. So I just have a blank project. And from the other project, we had these imports up here, but they're wrong now. So instead of a file input stream, we need a file output stream. And instead of scanner, we need a print writer. So is that complaining? That's the wrong name. Oh, it's java.io print writer, not java.util. Cool. All right. So file output stream, IO exception again, and print writer again. Also, I believe that the example in the PowerPoint or the PDF slides forgets to add this at the beginning, but we need throws IO exception here in the same way that we need it for reading files for the same reasons, right? When you try to write to a file, you might not be able to write to the file because you might not have permission. When you try to write to the file, uh, the disk might be full, right? There's all kinds of reasons why you wouldn't be able to write to a file. And those are errors, those are exceptions, and we need to handle them somehow. All right, so we just have a blank project here. Similar to the other one for input, we need to have a file name. Again, the file name does not have to be in a variable called file name. Um, you can call it whatever you want. It's really common to see this, like string fn. People just use fn for file name. And this can be anything you want, including you can put a full path here, right? So if I knew that I wanted to save a file in user ghogan42 documents, hey, this is a file.txt, right? Like I could do that. Assuming that this path is correct, will be okay later on. Let's try it. So you put a string for the file you're trying to write to, similar to this. Then just like here, you do a file input stream. Well, when you're writing a file, it's not an input stream. It is an output stream. output stream. And this also needs to be file output stream. So output. I wish this was not. Did I spell this wrong? What's it saying? File name. File name is not a type because I changed it to FN. Okay. So there we go. So you declare a string with your file name if you want. You make a file output stream. This is a bad name for it, right? FO. It should be like maybe FOS for output stream, or you can say like file. I typed words and it just deleted. Okay, file output. Man, it's going everything's really slow. You can call that whatever you want. It's kind of my point. File output stream. And then once you have a file output stream, we need to declare a print writer object. So this is the kind of similar to um, this is similar to declaring a scanner. So print writer, give it a name. What should it be called? Whatever you want, right? So I know that in the example it uses outfs, which is kind of a bad name, but I'll stick with it. And then it's a new, what is it? Well, it's a print writer. And we want to make the print writer for our file. So this output stream has to go into the print writer. So we do all this stuff. And so once we have a print writer, then we should be able to print to the file just by using the normal print line and printf functions. But instead of like system dot out dot print line, this should go in the file, right? If I do this and I run my code here, wow, a lot of lag. What do I get? This is not working for my file. Is it users? Cool. So I printed to the console, right? System.out print line prints to the console. If I want to actually print to the file, instead of system.out print line, you get rid of that and you put whatever your print writer is called. So out fs. So out fs, out fs. And then when I run this, we will not see anything in here. Nothing appears in the console because I didn't write this to the console this time. I wrote it to the file. Also, when you're done writing to the file, you should close it. So how do you close it? Out fs dot close. And that should be the name of the print writer. So we've written a file in theory. So where's the file? Well, on this computer, it's in users, ghogan42, documents. Hey, this is a file.txt. So if I go look for that in my documents folder, I see it. Look, hey, this is a file.txt. And if I open that up, uh, interesting. Look at this. It doesn't have anything in it. Why not? Let's run this again. Okay, now it says this should go in the file. So what might have been happening, I'm gonna like here, let me delete this. Oh, actually I'll put blah. Um, the first time we ran this, we didn't have the close, right? So if I run this, it runs. I come to here, I look, it's empty, right? It's empty. So if I want it to save, I need to make sure I close my file at the end. Now when I run it and I look in the file, this should go in the file. Okay, so make sure you close your files. We saw that it does make a difference here in Mac OS. Does it make a difference in Windows? Maybe, maybe not. That's because in Windows, well, the way that these things behave are slightly different between operating systems because it's really the operating system that's handling opening files and closing files and things like that. So, um, you should close your stuff, close files when you're done with them, to ensure everything works properly. And honestly, this is just about what we needed to cover in this video, except I want to give you an example that's similar to um, the lab. So here's what I want to do. So I'm going to open, I can open a new text editor here just to show you. Um, in the lab, you're going to have to create a file that looks something like this. You have X values, you're going to have like, I think sine X values. You're going to have like cosine values. And then you're supposed to have like these numbers, like this starts at like negative 1.5. And then this is actually, I have no idea. I have no idea. And then the next one is negative 1.4. And this is, I don't know. This is also, I don't know, right? And so like we're supposed to be like making a text file like this in code. And I want to do something similar, except we'll make it a little bit simple in this example. So what I want ours to look like is we're only going to have two columns like this. And maybe instead of sine X, let's do something else. Let's do um, let's do sine X divided by X. So this is what we're going to plot. And instead of starting at negative 1.5, I want to start at negative 3. And we'll still count up by tenths. So we'll go from like negative 3 to negative 2.9. And then like negative 2.8. And then we'll have to calculate these y values. So I want to make a file that looks like this. And maybe it goes all the way to like 3.0. So it's going to go from negative 3 to positive 3 on the x values, and the y values will just be whatever they are. Does that make sense? So how could we do that? Well, as I said, we can print to a file the same way we print to the console. So if you were able to do that to the console, you should be able to do it to the file. So let's pick a new file. So like instead of, hey, this is a file. Actually, maybe let's do this. Let's get rid of the path. And let's just put it in math.txt. Okay, math.txt. That's where we're going to put it. And for printing this, we can just print like we do to the console. So if I'm looking at this, this is my example. Like the first line is supposed to have some spaces and then an X and then some spaces and then Y equals sine X over X. So you would just do that. You just go X, I don't know, Y equals sine X over X. Cool, right? So if I run this now, run, then it should have put this into math.txt. Where's math.txt? Well, you'd have to open the project folder again, right? Because I didn't put the path. So I would have to click on SRC, right click, properties, open the thing, and we end up here. Oh, I clicked on SRC, so I ended up in here. I think the last time what happened was um, I clicked on the project name and then did properties and opened that up. I think it's going. and it highlighted the project, but we weren't inside it, so I still had to double click it to get here. So we come in here and then we have math.txt, and you can see that right now math.txt just has X and Y. That's all we've written to that file. We don't need this anymore, I don't think. Close and then discard. All right, so the file's here, and now let's think about how we're going to get all those things into into the file. Well, one way to do it would be to, if we need to write so many lines, right? If we're going to go to, let's try to do, we want to try to write lines for like x equals -3, -2.9, -2.8, all the way up to, I think we decided +3 is what I said, right? So if you wanted to do that, a good way to do that would be with a for loop. So maybe we would create a double called X, maybe also a double called Y, and then we can do it with a for loop. So we do for and X equals, we know that the first thing in the for loop it runs one time when you start the for loop. So at the beginning of the for loop, let's set X to be -3, our first value. And then we want to go all the way up to +3. So we should keep going as long as X is less than or equal to +3. I should put this in as 3.02. And you can't do X plus plus because X plus plus means add 1 to X. We don't want to add 1. From -3 to -2.9, we want to add 0.1. So that would be X equals X plus 0.1. Or using the simplified syntax, it would be X plus equals 0.1. Cool. So these are my X values. So if right now I just did this, out fs dot print line X, let's just see what this would look like. So I could run this. It ran. Have to go look at the file, and it looks like this. And, this is not ideal. I don't really like the way this looks, but you can see it does start at -3 and it goes up to 2.9, which is not 3, but we'll think about that later. Um, you can see a few things. First of all, floating point numbers are not exact. That's why instead of being exactly 2.7, exactly 2.6, it's like they're a little bit off. That's annoying. Also, look at how many decimals it wrote. I don't like that. So that's why we learned about printf earlier, right? Remember printf, we can do formatted text. So we can make a string and I could do, if I wanted like 2 decimal places, I can do %.2f, right? And then to get a new line, \n, and then put an X in there. And so that should round everything to 2 decimal places. So let's look at that. Ran it. Let's look here. Look at that. That's looking much better. I don't quite like the way that this is lining up, but I'm going to deal with that in a little bit. So you can see that the X values are basically looking good in here. So cool. What about the Y values? Well, for the Y values, if you're trying to plot a function y equals sine x over x, you have to calculate sine x over x. So in this for loop, we could do y equals sine x over x, except this won't work because the sine function, if you remember, lives inside of math.sine x over x. So now we've got the y value, and we just need to put the y value in here too. So you have to put another placeholder, like maybe like that. So x can go there and y can go there. And then you have to change the end here. Instead of comma X, you need comma X, comma Y to also put the Y there. Run it again. Let's look at it. Um, that's looking pretty good. Couple things I don't like. I don't like that the header, if you look here, I don't like that this is so far over to the right. We need to move it left a little bit. And also, I kind of hate the way that these line up here. And so let's fix the way that these line up. So the reason these are not lining up correctly is because they're starting at the same place, right? On the left side, it does line up, except that there's extra minuses here. And after you go to the positive numbers, there's no minus anymore. So it looks like they moved over to the left, even though really they started in the same place. They just don't have a minus sign at the beginning. Well, you can fix this. Instead of having them lined up here on the left, we can reserve a certain number of spaces for them. And so the way you do that is instead of dot two we know means like show two decimal places. You can put a number before the dot as well. And so like if I put like, for example, 8 here, that would be saying we want to reserve 8 spaces and we want to round to 2 decimal places. And you could do that on both of these. And 8 is more than we need, but I'm just going to put 8 anyway. So if you do 8.2f, let's see what it looks like. Um, close it and open it. Okay. And this looks pretty good. This looks pretty good. Right now, everything's kind of lining up a little bit better. Maybe we don't need 8 spaces, or maybe like we can get rid of space there. Maybe we only need 7 there. Maybe we only need 7 there. Um, and like this kind of process of formatting a file is kind of, you just gotta experiment until it looks the way you want it. I like this. This looks good. Um, what else would I like to change about this? Nothing really. It should go up to, I said 3, but we didn't go up to 3. Even though we typed -3 to +3 here, and we put -3 and 3 here, it actually didn't go all the way up to +3. And that's because these floating point numbers, these doubles are not exact. And so the one that's supposed to be 3 is apparently slightly bigger than 3 and gets cut off. So you'd have to fix that if you wanted that to go all the way to 3 just by like putting this slightly bigger for the cutoff point. And then when we look at it, it should go all the way to 3 now. Yeah, there you go. Maybe you decide you want more decimal places for the sine x over x. So you can go, let's show 4 decimal places. Oops, I typed 5. You know, it doesn't, we're not trying to do anything here. So it's just whatever we feel like. Yeah, something like this. That looks good to me. Cool. So that was just an example of kind of outputting a text file with actual information in it. So like we were able to make a table of X and Y values, and you'd be able to copy paste the values from there to like a spreadsheet if you needed them or something like that, um, if you are so inclined. Okay, well, anyway, I think that is everything I needed to talk about here. There's still a little bit more to talk about, but we'll go over the labs, not the labs, we'll go over the Zybooks assignments in the next video. And I'll post a little like 10-minute long supplemental video filmed in Windows regarding the paths to those files. Um, all right. All right. I will talk to you guys later, and I'm going to stop this right here.